So we started with GDP. I think I got this one the other day. GDP we said was gross domestic product, and people use that all the time, but for a macro class you actually want to know what that means. And we said, well, this means something really important. We called it the total market value of all final goods and services produced in an economy in a given time period, and the time period was usually a year. So usually your gross domestic product talked about this year's GDP was this year's GDP. And I think I put this up, right? 15 trillion? It's kind of in the ballpark. 15 trillion?
GDP is based off of certain goods, not all goods, though, right?
Final goods. Chapter 5, go deeper. This is chapter 2. Okay. 15 trillion, and we wrote it like this. It was a really large number, right? So 15 trillion is a large number. That's a whole lot of things that we're producing. And when we're talking about the stuff we're producing cars, we're producing education, we're producing donuts, we're producing TVs, we're producing a huge bundle of stuff. And when you total up the value of all of that stuff, it's $15 trillion, which is a huge amount of stuff, yes.
Okay. I think you got an extra set of zeros.
Extra set of zeros, so this is not trillion?
No, that's whatever's after trillion.
Which is bigger than trillion?
Bigger than trillion.
Okay, so you're telling me if I go back and get rid of 3 zeros,
Yeah, negative.
that's trillion?
100, 1,000, million.
So let's check. Ones, tens, hundreds, thousands, 10,000s, 100,000s, millions,
10 million,
100 millions,
billion,
10 billions, 100 billions, trillions,
10 trillion.
10 trillion, so 15 trillion. Okay, so we got the number. Fantastic. So what we use this number for is to say, well, if this number gets bigger, so suppose next year we have 15 trillion 500 billion. Some people would write this as 15.5 trillion. In my class, you might see both, so make sure you can toggle between the two. In this sense, we might say that the economy is growing. So the economy is getting bigger because it's getting bigger, we're producing a bigger bundle. And then people might also take the additional leap and say, well, since we live in the economy, we would also be doing better because we're producing a bigger bundle. Okay. Then we get to GDP per capita. Anybody know what GDP per capita is?
per person.
Per person? So GDP per person, could you come up with an equation?
GDP divided by however many people there are.
Great. GDP divided by the population. Fantastic. So GDP per capita is a measure of what each individual would get if we took GDP and sliced it evenly amongst everybody in the population. So everybody would get the same slice. So I can actually do this for this. We know that GDP is 15 trillion, right? 100,000 million billion trillions. Divided by the population. As I recall, the population used to be 6 billion, but now the population is 7 billion.
Per country, so just the US.
Oh, that's the population for the globe, and this is just GDP for the US. So I need just population for the US, and I'm going to maybe get you to, because you're going to answer, I know, right? Let's see if somebody else knows. Population? 315 million? How do you know that?
Yeah, I know it's about 310 million.
How do you know that?
That's what I read back in 2012.
2012, okay. So I'm going to use a rounder number, but I think you're right. He said about 300 million. So 7 billion for the globe, 300 million for us. A little over 300 million. Okay. I give that problem to my kid. My kid falls on the floor, starts kicking and screaming, going, "Why are you torturing me?" I say, "Relax, breathe, simplify, make it easier on yourself." Right? He sees all these zeros and he just freaks out. And then that, boom, no problem. I'm like, dude, those are the same problems. Why are you making it so hard on yourself? I have, is it Marcella?
Yes.
Yes. What is the average GDP in the US? So if we do this, this is what each individual would get if they got an equal slice of GDP. This tells us that slice. What is that slice? 50,000. Fantastic. So per capita GDP in the US, about 50,000. You say to yourself, okay, how do we use this number? We would use this number to say, well, if next year that number is, say, 51,000, then per capita GDP is increasing. We would say then people have a higher income and therefore maybe they're doing better. So maybe the welfare of the citizens in the country is improving. Fantastic. As soon as I see that number though, 50,000, I say to myself, I don't make 50,000. I don't know anybody that makes exactly 50,000. A lot of people make more than 50,000. A lot of people make less than 50,000. So we're not all getting the same slice. I'd be interested in what slice do we get? What is the slice of GDP that individuals get? So now I'm going to turn into income distribution. This is the answer to who gets the GDP. So we talk about, well, what do we produce? We produce GDP. We talk about who gets it. Well, maybe if everybody on an equal slice, it would be this, but we know everybody doesn't get an equal slice, so what slices do they get? And what I'm going to do is line up my population from poorest to richest. So I'm going to divide my population from the poorest people in my population to the richest people in my population. Think of the poorest over here and the richest over there. And I'm going to divide them into quintiles. Not sure what a quintile is. Does anybody know what a quintile is? Yes, by 5. So I'm going to divide my population into 5 parts. So there's 1 part, 2 parts, 3 parts, 4 parts, and 5 parts. So quintiles are, you could say, 1/5 or 20% increments. So this is 20% of the population, 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 this is 20% of the population. So I'm accounting for 100% of the population. And I'm just ordering them in this kind of case. My poorest 20% is this group here, poorest 20%. Then my next quintile, the next 20%. They're not as poor as this group, but they're poorer than this group, so the next 20%. Then I have the next 20%. Then the next 20%, and then you guys will be the richest 20%. So the richest, the poorest, and then a whole bunch of other people. So I'm thinking about what this might look like. Let me put it over here. I'm going to draw a graph. It's going to capture something about the income distribution for the US and maybe some other countries. And down here, I'm going to measure cumulative population in percentage, which is this part here, the ranking of the poorest to the richest. That's going to be down here. Then on this axis, I'm going to measure cumulative GDP or income. We'll learn this in chapter 5 in percentage. And I'm thinking about, well, what would that curve look like if I were looking for a reference point? So I'm looking for a way to kind of distinguish between what it might look like and what it will actually look like. And I'm thinking, well, a line of perfect equality is a good reference. If I know what that looks like, then I know what inequality looks like. So I'm looking for a line that maybe represents perfect equality. Maybe it looks like that. 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 Maybe like that. Like that. Maybe like that. Maybe like that. Maybe like that. Maybe like that. There's a bunch of them, right? That's just a sample of what they might look like. If you were trying to draw a line of perfect equality, what would that line look like? That would seem reasonable, everybody having the same amount. So does one of those graphs look like what you think it should look like? So one of these? Okay. You want to pick one? This one here? Okay. So one suggestion is that one. Other suggestions? Thanks for starting with. Yes, that would be good, but then I would have like 50 different. Perfect, yes.
One from third, fourth, second one closer.
This one or this one?
Yeah, that one.
This one? Okay. One for that one. Same kind of reasoning that everybody's getting the same share, so something like that, okay?
Are we talking about picking the same shape, or are we talking about like a perfect economy where?
I'm not talking about a perfect economy, I'm talking about perfect equality. I don't know how to define a perfect equality, but I do know how to define perfect equality.
And it's similar to what, in terms of income distribution, like socialist countries like Cuba or Venezuela.
Potentially. So potentially some countries are aspiring for this and some countries are not aspiring for something like that. That may be true, but I'm just trying to figure out, well, how do I show it in a graph? And then we'll talk about do countries actually achieve it or not. Yes?
So wouldn't it be pretty much perfectly horizontal?
Perfectly horizontal, so like this one?
Yeah.
Or maybe that one? Or maybe,
Because that would include everyone along the line. It would be, this is equal. No, not vertical, but not today.
this one? It may matter.
Well, I mean,
One person said it's this way, one person said it's this way.
well, I mean, like, depending on the overall GDP, that would, wouldn't that be how high?
It looks like, in my diagram, we're talking about percentages, so that strips away the actual number, right? Puts it in terms of percentage, so it changes a little bit, yes? A diagonal? What kind of diagonal? Because there are a bunch up there. Like this? So a diagonal from here to there? That's the right answer. How do you know that?
Using the same point on the graph or whatever, and then you can y-axis and divide by the x-axis, that would you make the number obviously.
That's exactly right. So if we say 20% of the population, if they were getting an equal slice, they would get 20% of the GDP. So this number over here would have to be 20%. And then if we talked about 40% of the population, they should share 40% of the income, and 60% would be 60%, and 80% would be 80%, and 100% would get 100% of GDP, and 0 would get 0. Perfect. So there's perfect equality. So this is a reference point for us to say, okay, this is what perfect equality would look like. If there were a perfectly equal income distribution, this is what it should look like. And then I'll tell you, nowhere in the world, even for the countries that are aspiring to have perfectly equal income distributions, no country can achieve perfect equality, or has not yet, right? Maybe in the future that will happen, but currently, no country has ever achieved this. That includes the US, Cuba, any other country. So if that's true, we don't have perfect equality, what does the line that captures inequality look like? We've got all of these, right? I think you were first and you came up just a second behind, yes.
Probably that line occurs inward like this.
So, this one?
Yep.
This one like that?
So when starting down in the bottom left, it kind of goes up, waves over, and then it goes up.
So this one like this?
Yep.
So one for that. Other suggestions? Yes?
Are you asking for perfect inequality?
Not perfect inequality, just some level of inequality.
Well, it would start.
I don't think there's any country that has perfect inequality. That means one person has everything, everybody else has nothing. That would be horrific. So just some level of inequality? Like this one? Yes.
Would it be any line except for that one?
Any line except for that one, but I'm trying to figure out, well, what kind of shape does it have?
I would say opposite of this.
Opposite of his, so this one?
Yes.
So one for Al. Others? I see potentially, yeah.
I would say it looks like a perfect quality line, it's bowing more down to the right, so starting bottom left and sort of swoop up to the top right.
Yeah. So the suggestion is, if we're plotting a line that shows some inequality, it looks like that. I'm going to call that the Lorenz curve. That's going to actually capture the income distribution. Why do you think it looks like that? Because that's exactly what it should look like.
Because at 100%, you still have to be at 100%.
Yes,
So it's kind of in that top right corner.
absolutely.
And we know the bottom percentage of society has very little, so it's going to be much lower than the perfect quality line.
Fantastic. So he's telling me my poorest quintile is not going to get 20% of the income. They're 20% of the population, but they're probably going to get something less than 20%. So they're not going to get that full share that maybe they would get if they got an equal slice. So you're looking at a number that looks like that. Fantastic. So then I've got some data for the U.S. I want to see what's the U.S. income distribution actually look like. So here are my quintiles. I'm going to have my poorest, 20%. I'm going to have my richest, 20%. And then we're going to be talking about all 5 quintiles. So this could be my second quintile, or 20%. Here is my third quintile, so that's my next 20%. And here's my fourth quintile. And then I'd be interested in the share of GDP or income, share of, in percentage. So what percentage did they get? I've got some numbers here. This is going to be for 1997. So this is the share for 1997. The poorest 20% in my economy got 3.6. The next 20% got 8.6. So they got a little more than the poorest group, but not as much as the next group. This next group got 14.9. This next group got 23.2. And then this happens all the time in economics. We're given problems and we're asked to kind of solve for something, and I say, okay, I want to solve for this income distribution for the U.S. What does it look like? I go out and I collect some data, but there's some data missing, I've been hired as a consultant, so I just hand the people that hired me back a document that's one page. It says, not enough information, and I leave. And then they never call me again. Because they said, you didn't do anything for us, right? We paid you to actually consult us, right? Which means figure out a problem, well, the solution to this problem. And I didn't do it, so if you find something like this, how would you find the missing component? What could you do? There's this missing information, but I need that to plot this Lorenz curve to talk about the income distribution, but it's missing, so I think I'm done. Yes?
Just all those in support, first, second,
Fantastic. So you said add up all of these, and then subtract it from 100. So we know the total of this pie, GDP, has to be divided in a certain way, but the total should be 100%. Fantastic. We've got 4 of the quintiles, so we could add those up, and then what's left over would go to this group. Great. What is the sum of these?
It's about 50.
It's about 50. I would say I want to be exactly precise.
49.7.
This part?
Yeah.
That's 49.7.
This is 49.7.
The other one's 50 to 100.
Somebody said no. I'll put a question mark there. If somebody got a different number, what'd you get?
You're right. Sorry.
50.3?
And
50.3?
I'm sorry.
So this is 50.3? This, that's,
the
That's
answer.
50.3. There you go.
so this plus this plus this plus this equals this? I see some head nods, okay, fantastic. So then 100 minus this would get me this number? 49.7, great. So I can put this 100 minus 50.3 gets me that. Fantastic. So now I'm going to go plot the actual income distribution for the U.S. So this is the real income distribution for the U.S. for 1997. The first point is the poorest 20% gets 3.6. So that's what they got. When I add the next quintile, so I stack that next group on top of the previous group. So now I'm talking about 40% of the population. This 20% added an additional 8.6, so I have to add the 3.6 plus the 8.6. 3.6 plus 8.6? 12.2?
Yeah.
So maybe something like that. It's cumulative, so 40% of the population shares 12.2% of the income. Then I take the next quintile, the third quintile, I add that to the existing part. So this is going to be 3.6 plus 8.6 plus 14.9. Twenty-seven point one. Maybe something like that. Maybe right there. Then I add 3.6 plus 8.6 plus 14.9 plus 23.2. 50.3, how do you know that?
Well, it's already established.
Fantastic, so don't do it again, but if you want to, you can, but it's right there, okay? So this is 50.3. That's interesting. If I stack the poorest 20%, the next 20%, the next 20%, the next 20%, they share about 50% of the pie. And then the other 20% gets the other 50%. Okay? Then if I add the next, I get to here. And of course, 0 equals 0. So this is the Lorenz curve for the U.S. for 1997. So one of the things I see is that we definitely have inequality. We don't have perfect equality, we have some level of inequality. And I start wondering about, well, is it getting better, is it getting worse? What's happening to the income distribution in the US over time? So I'm going to gather some more data. I'm going to get the share of GDP in percentage for 2005. So some years have elapsed, we have this new data that suggests maybe GDP is changing. .4, 23, 14.6. .5. Brianna. Yes. Again, some missing information. They didn't tell me what the poorest 20% made in 2005. They only gave me these 4 quintiles. I'm like, well, how much did the poorest group get? Great. Great. What'd you get? Okay. Sure. I think I have Eric next. So you would want to be proofing whatever answer she gives. 13.5?
Oh, 3.5.
Brianna looked puzzled. 3.5?
3.5.
Those are very different.
Yes.
3.5? Is it true? Yes. Always a good idea to check the mathematics. So when I'm asking an individual to do it, you should be checking it so that your answer matches or doesn't. And if it matches, you go, fantastic, I did it right. If it doesn't match, you say, well, maybe the other person did it wrong, or maybe I did it wrong, and we can reconcile it. That way, when you have an exam question, you know exactly the mechanics to do it. So always practice these. Good step. Okay, so here's the new income distribution. I want to plot this one. So the poorest 20% got 3.5 this time. The next 20% is added to this, so I've got 3.5 plus 8.5? 12? So 40% is 12. 3.5 plus 8.5 plus 14.6? 26.6? Okay. 26.6. Something like that. Then I've got 3.5 plus 8.5 plus 14.6 plus 23. 49.6. And then I've got 100 is 100 and 0 is 0. So here is the Lorenz curve for the U.S. 2005. So now I have some information to say, well, what is happening in the U.S. economy? I'm actually thinking about, well, how can I use this curve? One of the things we know is that as the curve moves that way, something's happening to the level of inequality. When the curve is moving that way, something is happening to the level of inequality. So I'm thinking right now, we could write a headline for the SAC-B that said something about what's happening to the income distribution in the U.S. What do you think is happening? What would your headline read? SAC-B, bold print, boom. increase in inequality. I like it, right? Increase in inequality. And why do you say increase in inequality? Fantastic, right? Econ is so easy. I don't know why people have such a hard time. It's really not easy, right? So if you're moving this way, you could say there is an increase in inequality. Or you could call it less equal distribution, but I like the wording. If it's moving this way, so if it's getting closer to the vertical equality line, we say a decrease in inequality. Well, I guess the wording might be interesting, right? So instead of calling it an increase in inequality, we could call it a decrease in equality. One of those feels better, right? If you're reading that, you do feel differently about the wording of this and this. They both are suggesting the same thing. A decrease in inequality or an increase in equality. You feel differently about those two, so the choice of words maybe matters, right? So I'm looking at this saying, wow, income inequality is increasing in the US. I think we all knew this, right? We've been hearing about this for quite some time. This is actually the data that supports that income inequality is getting less and less equal. So then I'm thinking, well, my story kicks in, right? That's the positive. I'm now normative, and I'm thinking, well, I like equality. So I'm going to come over here. I'm going to take some. What do you guys have? You guys have way too much, right? You have half of the pie. Way too big a slide. So I'm going to take some of it. Give it to you guys. Give some to you guys. I'm going to give some to you guys, and I'm going to give some to you guys. And if I do that, what do you expect to happen to Lorenz curve? Fernando. Fernando.
Yes. Will it go closer to equality?
Right. Super easy, right? So if I take some from this group and spread it over to this group, the Lorenz curve will start moving closer and closer to perfect equality. And depending on how much I reallocate, I'll see how far I go. Fantastic. So in your textbook, I think you guys have 2008. It'd be interesting to know, has the level of inequality continued to increase? Or has it started to go back the other way? Something you can do on your own. I'm not going to do it here because you know the mechanics, but it might be interesting. So I can look at a country over time with the Lorenz curve. That's an interesting kind of thought process. I can also compare my income distribution for my country to another country's income distribution, which might be interesting as well. So I can do something like this. I'm going to do some abbreviation here. You guys should never do that. You want your instructor to know what that is, perfect equality. You should write it out. Cumulative population in percentage, but you should write it out. Cumulative GDP or income in percent, but you should write it out. And then I might say something like this. Well, here's the US Lorenz curve. And then I would want to compare our income distribution to some other country. Call it Brazil. And Brazil has historically had one of the most unequal distributions on the globe. So when we think about Brazil, we think they have a really unequal distribution of income. So SACD headline, yeah, US income distribution is becoming more unequal, comma, but we have a more equal income distribution than Brazil. So maybe we feel a little bad, and we feel a little better. It's not as bad as it could be, maybe. Then I say, well, there are countries that have more equal distributions of income. So we have countries that have more equal income distributions, and that might be a country like Japan. So now I can compare not only my country, I can compare my country to other countries. So I've got over time, how's it changing for an economy? Then I've got, well, how do I compare it to another country? And then I guess I could mash both of these together and see, okay, well, we are more equal than them, less equal than them, but what's happening over time? How are these curves moving? Is this curve moving this way and ours is moving that way, and eventually they'll cross and we'll become one of the more unequal distributions in the world? Or are they moving in some other fashion? So really kind of useful tool for looking at income distribution. We know people don't get unequal slides. What slides do they get? Economic growth. In chapter 1, we talked about economic growth in terms of the PPC. In terms of the PPC, I can't remember what the PPC was. America. Yes. What is the PPC? Production possibility curve, okay. What does it mean? The? You see it? Yes. Where is the, are you the? You? Yes. So the production possibility curve, somebody said that, but what does that mean? So I'm the person on the street, you're using all of this fancy language to say, oh, the PPC, and I'm just going, what does that mean? You gotta put it into words that people will go, oh, now I get it.
It's a diagram that shows the curve and the possibility.
Yeah, I still don't get it. Yeah?
What amount of product gets produced even used?
Yeah, but not quite.
Would you like to read out of that? And it shows how much of one product you can sell more than the other. So like if you sold more TVs, then you could sell less soap or something along the lines of that.
Oh, this is nothing about sales yet, only production. So we're only talking about production, right? Not sales. Sales will come, not yet, chapter 3, yes?
These are just distribution for different like products, so that you figure out what amount of purchases you need for one in order, and then like distribute them between them, finding out like how much you make for this amount of product for this amount one, and then this amount of product for the other one.
So no doubt that you all know what I'm asking for, but so far nobody's given me the exact thing I'm looking for. I'm looking for something like the definition for GDP. Everybody kind of understands it's gross domestic product, but what is it really? I'm doing the same thing here. We all kind of know what the PPC is, but what is it really? That lengthy explanation. As soon as I say that, a few more hands went up. I think your hand was up first, so I'll go with you first.
All possible combinations of two products you can make using resource technology.
Fantastic. All possible combinations of goods and services, in this case it's just two, right, that we can think of the larger economy. So all of the possible combinations of goods and services that can be produced, given, you said, resources and technology. So that limits us to be here. Fantastic. And so in chapter 1, when we talked about economic growth, we were talking about the PPC shifting out this way. So shifting the PPC out through this economic growth. So I have a question. The entree. Yes. How can I shift the production possibility curve out? There's two ways that we talk about.
Producing more of one item.
So producing more, that's what this would capture. But how can we produce more?
Not producing more of the other.
No, that's the opportunity cost. That gets me from one place on a PPC to another place on the same PPC. I want to actually go to a new PPC. I saw a few hands over here. Yes?
Increasing resources like labor.
Increasing resources. And you would say, well, there's the 4. 1, 2, 3, 4. Man, labor, capital, entrepreneurship. Increase those, that will shift this out. And then the other one? New technology. Fantastic. So that's how we talked about it in chapter 1. In chapter 2, we use GDP. So in chapter 2, we talk about economic growth too, but we use a different mechanism. In this case, we talk about, I'm going to call it GDP growth, or you could call it the GDP growth rate. And this is GDP new minus GDP over GDP old. So if we have some data, and I'll give you some data, you can just plug that data into this equation, and by using that equation, you can solve for the GDP growth rate. And we think that when you do this calculation, for the US economy, it's about 3% per year. For China, it's 10% per year. So people start to wonder, well, why is this country growing faster than this other country? What are the implications for that? We'll get into some of that later in the course, but right now I just want to know, how do we measure GDP growth? If this number is negative, then we're starting to think about an economy that's in recession. So we're usually using positive numbers because we want economic growth to be positive, but sometimes the economy stumbles, and when it does, this might be negative. And we start thinking about recession when that's negative. Fantastic. So I've got the GDP new minus the GDP old over the GDP old. So in our example, I took some fake numbers, right, and said, oh, I think GDP is this, and it's growing at about this one. So let me give you some real numbers. These numbers come from your textbook. Oh, I don't have a small enough gap. Does anybody have the textbook? In your textbook, either somewhere in the front or somewhere in the back, there's a table of GDP numbers. And I'm wondering if you can maybe give me, I need 2 data points, and one of the points I have is, well, I have the year. I have a year here called 2008. And then I would want to get 2007 because I need the new minus the old over the old. And I have the GDP number for one of these years. For 2008, I have a number that says it was 14,265. So that was GDP in 2008. Can you find that GDP number for 2007? Looks like you found it. Looks like it's in the back. 13,808. Thank you very much. So this is recorded in billions. So in the table, it says these numbers are in billions. So this is 14,265 billion, which is 14.265 trillion. This is 13,808 billion, which is 13.808 trillion. Great. So I can plug this in here. 14,265. Since they're all in billions, I'm not going to write out the whole number. So that's that. What is this minus this? So 14,265 minus 13,808. 457, thank you. Divided by 13,808. And then I'll pick a random student for the stock assignments. I have something I can't read. A-M-N-I-T-P-A-L. Last name, that's you, yes. What is the answer?
I'm looking at it right now.
Okay, fair enough. Go ahead. On deck is Kate. Thanks, Kate. Great. Great, you're doing the calculations just as expected. I'm expecting about 3%. Expecting. It's 3.3? Wow, perfect. So it's 0.03, that's what you got? 0.3? 0.33? I want to get every little bit right. 0.3 am I nodding? So this I can convert to a percentage by multiplying by 100. So this times that gets me a percentage, so this would be 3.38%. Fantastic. That's kind of what we think the US economy is growing at. So when we see a number like that, we go, oh, the economy is doing fine. When it gets lower than that, we start to get concerned. If it gets too high, we start to get concerned too, is the economy going to go too fast and overheat? Fantastic. Let me stop there.